All right, welcome everybody. Thank you so much for joining us for today's CELaRAI Bimonthly Talk Series. I'm Kristen Smigelski, Project Manager for the Center for Early Literacy and Responsible AI. We are so excited to continue this series exploring responsible AI, early literacy, and human-centered learning. And as always, please feel free to add your questions throughout the session using the Q&A feature. We'll save some time for discussion at the end, and we really look forward to engaging with your questions. We'll also share our website and LinkedIn in the chat so you can stay connected and access our recordings of past talks. Now I'll pass things over to our center's PI and director, Dr. Christine Wong.
Hello, good afternoon. I hope everybody can hear me clearly. I'm delighted to welcome today's speaker, Dr. Devin Kearns. Dr. Kearns is the Goodnight Distinguished Professor in Early Literacy at North Carolina State University. His research focuses on the cognitive science of reading, bringing together insights from psychology, cognitive science, and neuroscience to better understand how children learn to read. In addition to advancing reading research, Dr. Kearns also develops evidence-based instructional programs to strengthen students' reading skills with particular emphasis on multisyllabic word reading, content area literacy, and intensive intervention for students who need additional support. His work has been widely published and cited. He currently serves as the chair of the Scientific Advisory Board of the International Dyslexia Association. He also serves on the advisory board for the CELaRAI Center. So in today's talk, it takes a triangle, the cognitive science of learning to read in English. Dr. Kearns explores one of the most fascinating questions in literacy education. How does the brain learn to read? He will also discuss what the cognitive science tells us about effective literacy instructions and how educators can apply those findings to better support developing readers. So, Dr. Kearns, we are so grateful to have you with us today. I'm really looking forward to learning from your presentation. So I'll now turn it over to you.
Great. Well, thank you, Christine, and thank you for your leadership of the CELaRAI Center. If you all don't know what CELaRAI is doing, you should visit the website to learn more. That's really exciting work. I've been really privileged to be involved. So thank you for inviting me to join you all. So Christine already gave me a nice introduction. Thank you for that. I'm going to go ahead and share my screen and get started with that. Can you see my whole screen? It takes triangles to show up there. Christine, can you see it okay? Kristen?
Not yet.
Not yet. Okay. How about
Oh,
now?
looks like something's loading. Yes, yeah, we can see it. Thank you.
Okay, perfect. Great. All right. So I'll keep the chat or the Q&A window open. So if you have questions during the session, you can ask them. If they seem germane at that moment, I can answer them, but we'll also have time for questions at the end of the session as well. So let's start talking about the cognitive science of learning to read in English. I'm going to talk about four things. I'm first going to talk about something called the word superiority effect, which explains how we actually perceive words in terms of multiple dimensions. And then I'm going to talk about the lexical quality hypothesis, which is about the features of words we learn and the fact that our knowledge of those features varies. I'm then going to link those things to something called the connectionist model or the triangle model of reading. And this is a model that shows us that we actually learn to read without rules, which has implications for what it is that we actually teach. And then I'm going to finish by giving you some of those implications. So I hope that that will be a useful hour for us to spend together. I've spent a lot of time trying to make sure that this will work pretty well today. So we'll see how it goes. Okay, I want to just briefly talk about my background a little bit further, the part that you don't usually hear about in a beginning of a presentation. I want to talk about just why I think it's important to do the kind of science-based research that we do, the kind that focuses on the combination of cognitive science, psychology, education science, and increasingly computer science, because when we don't do things in a science-based way, things don't go well. And the first example that comes from my family, I have two younger sisters. This is my youngest sister when she was 2. But when she was 6 and had to learn to read, and I was helping her with like the reading homework, She really hated it because she didn't know how to read the words. And I didn't really know how to help her because I was 13 or whatever. But when I would help her with the reading homework, she just, you could see her little fist ball up and she just looked so sad. And it was, the first time I ever really got interested in how it is you could help somebody do something themselves that was a little easier for you. And so that's kind of what inspired me to become a teacher. And what I didn't know then, but learned later, was one of the challenges for her had been that she hadn't been given good reading instruction. She was born in 1984, which means that she went to elementary school in about 1990. And that was right around the time that the whole language movement started. And so she didn't get good instruction on how to read words. And that had really bad effects for her in the long term. So I did become a teacher. I'm now, of course, a professor, and I'm going to show you the other half of this picture because it's sort of, people say this is how you know I was going to be a professor. So this is me. I'm 8 here, and I am wearing penny loafers and black socks in the summer. So most people don't do that. I still have penny loafers, not those exact same ones, but I just got some that are the same color because I like them. But I did become a professor, but for a long time I was a teacher. I taught for 7 years. And I taught third grade. This was me teaching third grade, and I taught in the Linwood Unified School District in Los Angeles County. And when I taught, I was also given bad instruction on how to teach kids to read. And in my first class, I had really low performing students in general. And I always highlight like my two lowest performing students, Sergio and Rosa, who came to me with kindergarten level reading skills. And even though I worked really hard and they worked really hard by the end of the year, they still couldn't read. And what I learned later, after doing some professional learning on the science of reading, I realized that the reason they didn't improve was because I'd been given bad knowledge. Of course, I was a new teacher too, that was part of it. But even after I was more experienced, my second year, I still had kids who struggled. And finally, then I know that it wasn't just me. I know it was what I learned because Jaime and Adolfo, after I learned all of this important stuff about the science of reading, they made a year's worth of progress in 3 months. I had students who, didn't like, I had one student I thought would qualify for special education services because of her difficulty with processing. And she didn't because she could read. And so I know that that's really important. So that's why I do this work. If I bring it to you, and I also find that in my work, I've always thought we need to bring together the disciplines that can bear on what we do, and one of those is cognitive science. And so I want to talk with you about how it is that cognitive scientists have identified that we read words because it has implications for what we do. So the first thing is this thing called the word superiority effect. And this is designed to show you that we use multiple sources of information when we read, okay? So to do this, we're gonna do a little experiment. I prepared this for you. I've never done this before. I prepared this for you all. We're gonna see if it actually works on the computer screen because it involves some auto timing. But in this experiment, you're gonna see this little cross, then a column of characters, and you're gonna try to identify as many as possible in the time given. Okay, so here's this little cross that you're going to see. It's going to go away. Characters will appear. You're going to identify the characters and then they'll go away. All right, so let me show you what this is going to look like. I'm going to press the button now and you'll see the characters hopefully in a moment. Okay, so the characters were there. The characters went away. What did you see? So you don't have to put in the chat or anything, but these are the things you saw. Okay, you saw a pound sign, an asterisk, and an ampersand. And so that was what we did. So that was an example, but this is not the real example. This was just to show you how this is actually going to work. So now we have the first example. So that was the first one. So you saw the cross, then you saw a column of letters. And the question is, how many of those letters did you see? So what did you see? I'm going to show you again at the end what you actually saw. All right, let's do another one. This time it's going to be something different. Let's look at these. Okay, and so the question there is, what did you see for that? So the question is, what did you see better? What was faster for you? How many of the words were you able to identify? The way to think about faster is how many of those could you actually identify after looking at the list? So is it more of the letter ones or more of the word ones? And let's see. Kristen, can people type in like the Q&A so I can see what they're saying, or is it?
Type in the Q&A, but it'll just submit it like a question, but they're more than welcome to do that and we can see it.
Okay, cool. So let me open that. Okay, so I saw, so Loretta, Emily said more words. Drew says more words. Um, so Matt had the same. Okay, so we're getting a lot of word answers here, right? So that's pretty, so think about that for a second. The ones in the left column are just letters. There's one letter. There are three letters here, and yet you were able to perceive more of those. This is the word superiority effect, right? And what you examine and what you describe is exactly what the researchers found in the original study. So just to kind of show you what this word superiority effect study, what they did is they did two experiments. They asked adults to read a series of letters, and they asked how fast they read each letter. And so they did this, and they found that it's about 250 milliseconds to read each letter. They then did the same experiment again, but with a series of words, and they asked how fast they read each word. And they had longer words, and they found that it took about 250 milliseconds. So you all, a lot of you said that you read more words, but that in this study, they found it was about the same for the letters and words. But there are multiple letters, and multiple letters in the words, and then there's only one letter. Why is it that they would be at least the same or maybe even better for the words, right? And what's fun, I always like to point out, this is not new information. So this study was done in 1888 by Quetzal, who is famous for being one of the ones who designed kind of the idea of IQ. But this was a study that Cattell did to kind of show that there's something about words. So why is it that we are able to do it faster with the words? It's because of the overlapping information we get from all of the letters. So what this tells us is that our perception isn't just one thing at a time. We're perceiving multiple things at the same time. And because of this, we're actually able to process a whole word faster than we're able to process a single letter because we have more information coming at us to help us identify that item. So that's the word superiority effect. So why am I telling you this? Well, it has a couple implications for the way we think about teaching reading. First, this is why whole language is wrong, or one reason whole language is wrong. So if you read the original papers on whole language, they thought that students should use as few letters as possible. Here was what one of the whole language folks wrote. Ken Goodman in 1967 wrote, efficient reading does not result from precise perception and identification of all elements, but from skill in selecting the fewest, most productive cues necessary to produce guesses which are right the first time. And that is totally wrong. And one reason I can tell you that's wrong is because of the word superiority effect, right? That word superiority effect would not produce a faster response if we were only selecting a few things. So precise perception of all the elements is important, not because you're looking at one thing, because you're looking at multiple things at a time. But because they thought this gave us a couple really bad strategies. One was contextual guessing, where they suggested as soon as you can figure it out, just guess based on, the large gray animal was called a blank, and there's an E in a long word. Well, you say elephant, right? But that is a bad strategy in most cases. It only works about 10% of the time, researchers have estimated. And that's a really bad thing. The other thing it brought us was get your mouth ready, which is one of the most confusing things. This comes from a really popular way of teaching reading. And basically the idea is that if you start to say the first sounds in a word, it'll kind of prime you to say the rest of it. So you get your mouth ready. And they called it Lips the Fish because they created this name of it, this Get Your Mouth Ready thing in the 90s, like I said, the 90s. And there was a Beanie Baby called Lips the Fish. That's where the Lips the Fish thing came from. But basically, it was the idea of get your mouth ready. So this is important because it brought us that really bad information. Why else does this matter? It also matters because of the way we should think about phonological awareness. So one really important thing that's come up a lot in the last couple of years is whether or not phonological awareness should involve letters. And what I just described for you about the word superiority effect in terms of helping us with reading is it helps to link the sounds to the letters. Because the more information we have to help us process the words, the better it will make us at everything. So when we're linking sounds to letters, it improves this entire system. And you'll see more about how that system works a little bit later. But basically, we want to give students access to as much information, right? As soon as kids start reading, linking the sounds to the letters is a good idea. It's still good and helpful to focus on the sound element of it. So one of the things that's important to know about reading and sound processing is that kids with reading difficulty have difficulty processing sounds. And one of the difficulties they have is identifying the categories of sounds and breaking words into individual sounds. So it's important for kids to get this idea that spoken words are broken into individual sounds. Some of you may have heard Mark Seidenberg, if you know who he is, he's a cognitive scientist who said recently, like, phonemes, sounds, and words are made up. And he's right. That's actually true because we don't perceive speech that way. It's a continuous stream. But what is important for reading is we actually have to convince our brains that there are individual phonemes because the written language works that same way. So once you begin to read, it's really important to use the letters. Of course, it's still helpful to understand that spoken words are broken into these pieces. So even before you start to read, before the students start to read, the PA practice on its own will help because it builds this idea students have of how the words are broken into individual sounds. And in research where they've shown that if kids don't begin kindergarten actually understanding that idea, it's really problematic. But there's no reason to, sometimes people say you can do phonological exercise with your eyes closed, right? Which is true if you don't use letters, but the data suggests that using letters is better. And there's data from a meta-analysis by one of my colleagues, Melissa Stalega, and she did an analysis to show that when you look at intervention and instructional studies involving phonological awareness, kids did better on word reading after phonological awareness training when there was a connection with the letters. So it's good to do that. And the word superiority effect shows us that multiple sources of information are better. And that's why that's important. So this is my first key idea. We use all the information we have all the time. And so it's important to give kids all of the relevant information, never tell them to guess, and link PA to letters. And I should just add about linking PA to letters. You can still focus on the sound. So one exercise that's really effective is like a word tile exercise or an Alconen box exercise with letters, where you have kids, with tiles, you can have them move the tiles around and make words using tiles. You can put a letter pattern like, say, CK representing the K sound on one tile. So students can use that tile to represent a sound. So they're still focusing on sounds, but linking it to letters. Okay. So the second thing I want to talk about is this idea of lexical quality and the lexical quality hypothesis. And this is about the idea that we perceive meaning features. And this is really, and that we have different quality in our understanding of those features. So first, let me explain what the lexicon is. So the lexicon is our mental dictionary of words. So I tell you, and I say this because I always had a hard time before I started studying this, I was like, what do you mean by a lexicon? A lexicon is our mental dictionary. Our lexicon, before you learn to read, your lexicon contains the spoken form, and you'll see more about this in a little bit, but the spoken form, the meanings of a word. And then once we add in letters, then the lexicon incorporates that information as well. And you'll see, I'll show you what that looks like in a little bit. And so our lexical quality then means the amount of information we have about the word's pronunciation, meaning, and spelling. And what I want to make clear is that it's the amount of information across features. And I'm going to explain what I mean about features. Okay. So I'm going to talk to you about the lexical features of an animal. Okay. And I want to talk about an animal that you can pronounce. So this is the pronunciation cat. Okay. So our lexical representation of the word cat involves the cat. But also, remember we said multiple sources of information. So we're not only perceiving all of the individual phonemes, but we're also perceiving, and this is auditory, the ka and the cat, but even if it's in another word, like you can see there, that's actually scatter. So you can see here, like scatter has the cat in it, but this is part of our perception. When we hear cat, we connect it to all the other things that we know about words that have cat in them. We also have meaning information. Cats have a lot of features, and we're going to talk about meaning features a lot because They're really discrete in a way that's easier to help us think about them. So cats have things that they do. They purr, they hiss, they mew, and so on. They have things like, they have pointy ears and eyes and whiskers and claws and a tail and so on. So it has these meaning features, right? These are the features. There are more of them too, and I'll say more about that in a little bit, but those are some basic features. And then you have how to spell it, right? So CAT, but also remember we're connecting this with other examples that we have. So CA in cart, for example, and I've intentionally spelled them. Typically spellings aren't connected with the pronunciation of cat to make clear that this is about the spelling. So we have this representation of the letters, and when we see it, we're thinking about the connection between the C and the A, even though we aren't necessarily thinking about it immediately linked to the sounds in cat. And I'll explain more about that in a little bit. So let's talk about how we know how to say a word and when lexical quality is poor, what happens. So if I say to you, what do you call a CAT? Or, or you're a reader and I'm actually showing it to you, but let's just say I'm saying it out loud. So you say, what do you call a CAT? And you say, and then you mumble, and then you say the T sound. It's not clear whether or not you think it's cot. That's the cot, the way you write in the International Phonetic Alphabet. By the way, I'm going to use the International Phonetic Alphabet today. I'll explain when I think it might be confusing to you, but the reason I'm doing that is it's kind of like the technical language of sounds, and so I always like to do that because as long as somebody explains it to me, I always feel like it's helpful for me to learn kind of the technical stuff. So that's why I do that. So that's cot. And it could be kit, right? We don't know which of those it is if we don't know all of the sounds, right? And so you have to know all of the sounds in the word. And this is also true for us when sometimes we don't know all of the sounds. So just to give you a couple examples, like the first one is, what is this called, right? So if you can think in your mind, like, what do you call this? Well, I would call it an asterisk, which I actually said earlier, but some people call it an asterisk, right? Or asterisks. I'm not actually sure how else you'd say it, but I think I know people say asterisk, right? Asterisks, yeah, asterisks, right? It's asterisk, right? But people say asterisks, and which makes sense because it's pretty similar to the actual word. I'm even having a hard time saying the wrong one, but we have different representations, our lexical quality for that. There's also one about a kind of nuclear energy. And so we often think of the word nuclear energy, but as you may know, I made this recording. Hopefully you guys can hear the sound. I don't know if I set it up for the sound to be audible. Did I do that? Let's see. Let's see. Not sure. But I'll play it. If you can't hear it, I'll just tell you what it is anyway. But this is a famous person saying. So I don't know if you heard that, but that was George W. Bush saying nuclear, which is not how you say the actual word, right? His lexical quality for that type of energy was not perfect, right? And then we have, of course, a small, strong shot of coffee associated with Italy is called espresso, right? People often say espresso. So our lexical quality for the word can vary even as adults, okay? Let's talk about meanings of words, right? So we know about cats, like we know different meanings of cats. I talked about some of the features. Well, one feature you may not know is that cats can't taste sweet things, right? So you may not have known this feature that a cat does not have many taste buds, right? So that's something that a cat doesn't have. Just as an example, our own lexical quality for meanings varies. So I like to talk about a word that is from a song that I grew up with, which is the word ironic. So some of you know the song that I'm talking about that features the word ironic. And there are a number of examples in which the artist uses the word ironic. And so here are the examples. The first one is that it says, a black fly in your Chardonnay. And the thing about that example is it's not really ironic, right? You could say that it's gross, but it's not really ironic, right? It's missing this element of kind of the unexpectedness that kind of goes with ironic, right? There's also rain on your wedding day, which is disappointing, but also not ironic. Good advice that you just didn't take. Well, that was a big mistake on your part, but it definitely wasn't ironic. And then having 10,000 spoons and all you need is a knife. That is ironic because the fact that you have something that's close to what you need, but not actually what you need is the key to being ironic, right? And so this is what makes it really hard, is that if you don't have all of the features of the word, it makes it hard for you to distinguish things that are ironic from things that aren't. So the quality of the artist's meaning representation for ironic could probably improve. Okay, so that's just an example of how our own lexical quality for meanings of words can vary. And no offense to Alanis Morissette, if you know, she's an amazing artist. I like her music, but I always just found that funny. Okay, last thing we know about is, what do we know how to spell a word? So if someone says the word is cat and I know there's an A and a T, but I don't know that first sound because it could be a K or C, or maybe it's CH because I've heard of chemistry before, right? Then I don't have a strong lexical representation for the spelling of that word. And this happens for adults also. So I want to give you some word examples. And so I have on the left side some examples of words where your lexical quality for the spelling might not be complete. So here are two spellings of the word threshold. And the question for you is, don't Google it because you're at home. Sometimes I've done this activity live and then people can't do that as much. But since you're home, you probably could. But try to see if you can figure out which of those is the correct spelling of threshold. That's the answer. So it's the one on the left. Oops. What happened to oh my gosh, it went all the way to the end of the presentation. That's not logic. Okay, hang on. Let me get that back. Sorry about that. Let's see. Sorry, this is what happens when you have a very large slide presentation. Let me just turn off the screen for a second so I can find where I am. All right, give me a second, everybody. I'll get there. Okay, here we go. Okay, and share. Let me just switch these windows. Okay. All right, so that was we did threshold. Let's do receipt. So receipt, here are two spellings of receipt. Which one is correct? That's the one. Here are two spellings of judgment. Which is the correct one? Well, it's a little bit of a toss-up. So technically the one on the right is correct, but if you're in Britain, it's the one on the left. Also, I noticed this really at Planet Fitness, it's also the one on the left, but technically it's supposed to go on the right. And then which of these is the correct spelling? Ophthalmologist. And the answer is neither of those. Those are both wrong. This is the actual spelling of that word. So I just may give that example to mention, even as adults, our own lexical quality can vary for these things, right? So here are the implications for us in terms of how lexical quality matters. We use this lexical knowledge whenever we read. Reading requires high quality lexical representations, meaning we have a lot of that information. It doesn't have to be perfect, but we need a lot of information, and it occurs in terms of the features of the word. I also want to point out that lexical quality improves every time you encounter a word. So I made this kind of like, you know, I don't know, brightly colored so you would remember. We can remember a word almost perfectly after just 3 to 5 encounters with it in print. So there's a researcher, Frank Manis, who did a study a long time ago now, but he showed that basically you commit these words to memory after 3 to 5 successful encounters, meaning you actually got it right when you read it, or you got corrected and you got it right, then you can remember that. So lexical quality matters a lot. And it also matters in terms of what we learn. So the second key idea is that our lexical quality improves over time based on practice and experience. When I say practice, I mean having a lot of opportunity to access words, which is why when we design reading lessons, we need to be really efficient in terms of the instruction so kids have lots of time to practice. The experience also matters in the sense that we have to be very careful about what it is that we give kids to read. We need to be strategic about the kind of text that we give them and the experience that we give them in reading. And data indicate that it's not just a matter of, say, using decodable text, because we think, oh yeah, decodable text help control the difficulty. That's true, but the disadvantage sometimes for decodable text, because there are benefits to them, is that it limits the range of experiences such that you can't generalize as well to other things. And you'll see more about that when I talk about the connectionist model in a minute. But basically, it's really important for us to design experiences that maximize student response. Okay, So that brings us to the triangle model. And the triangle model is about how we recognize words. And this is about how we do that without linking letters and sounds. So, sorry, without rules to connect letters and sounds. So this is the triangle model. You may have seen this before in a paper. And if you're not familiar with it, I'm just going to describe it to you briefly. So we have spelling, sounds, and meanings. We already talked about that, so that's great. We talked about that. We talked about the features of those things, right? And we have cat, which is C-A-T, and we talked about it's not just the C and the A and the T individually, but we perceive those subunits in them. The same is true for the sounds in cat. And of course, we have the cat itself. But remember, too, that the meaning isn't just the cat, it's the label. So when we say a word, one way to think about it is like a label that we give to a set of features. Because as we said, a cat has things that it does, things that it has, and things that it is, like a mammal and a predator, right? So we use the label cat and the spelling of that label, C-A-T, to represent this set of features. So the meaning is a set of features. And this is important because we think of it as a single thing, but really it's a collection of features, and we call that collection of features a cat, right? So this brings us back to the triangle model. I'm going to explain how we develop our understanding of a meaning of a word. And I'm going to talk about this for the moment anyway, without letters. I want to talk about how we learn things without rules. Because people say like, well, that's a cat and that's not a cat. But the fact is that we had to learn this, right? We learned to connect the features to the label. And this little thing in the middle, I'm going to spend some time explaining to you. But I first want to show you that we actually learn without rules, right? Because if you think about it, think about a toddler trying to learn the labels for things, and it looks at something and it says that's a cat, right? So it sees something that has paws, meows, is little, and is tame, and it will call this child will call that a cat, right? And then they won't say domesticated, but they say cat, right? And then they see something that has paws and barks and they know is tame, and that's a dog. So they have this label that goes with it. Initially, they might call a cat and a dog both dogs or both cats, but they learn to distinguish them over time as their understanding of the features grows. So they learn more about the features associated with that label. So then they learn that this thing that is big and roars, that's a lion, and that this thing that has the spots and roars, not as loud as a roar, is a leopard, right? But what's also important is that when we do this, we develop our knowledge such that when we get new examples, we decide what those are. So this is also an animal that shares many of the features with a cat. It's a cat too. It's an Egyptian Sphinx cat that doesn't have any hair, but that is still a cat and it's domesticated. But the question is, would we give that the label of cat? I'm assuming most of you would agree with me, it's a cat. But whether or not you say it's a cat depends on your decision about whether it's a cat. And this is the key point, is that we choose the label based on our experience and there isn't a rule. So I'm going to show you how this happens because I want to make sure you get this idea that we develop our experience in a way that doesn't involve rules, but looks like it does. And what I'm going to show you is the result of a model that I constructed based on so the model I'm going to show you I constructed is based on some work initially done by my colleague Matt Cooper Borkenhagen at Florida State. And so he designed this kind of simulation. I've expanded it. But what this model does is it categorizes animals without having any knowledge of categories, okay? And I'm going to show you how this happened. So the way this happened is this is a computational model. It's a computer model of learning. And that's what we're going to talk about, computer models of learning, because this is the key to helping us understand how reading really works. So the model, just like a little kid, was given the features of an animal, just like you could perceive it with your eyes. And then the model gave its best answer, like a kid would, for the label. I, as the teacher, or the computer, but I, as the teacher, told the student that's a cat or that's a dog or whatever it is, whether it's right or wrong. It learns by changing based on feedback, and then it tries another set of features, okay? And so it does this over time. So we have 40 animals. I'm not going to show you all there because they're right here. So here is a model that learns to label the animals, okay? So here you have a collection of all the animals. They're not really well distinguished. What I'm going to show you is how they get distinguished over time. I think I need to press interplay. So we'll see this. So just watch what happens over time. Okay, so what you saw at the beginning was this is a model that doesn't know anything. It had all these items kind of clustered together, right? In this kind of big mess. And by the end, it looks like this, right? And we could categorize these. I could say these are the big cats, these are smaller cats, these are other terrestrial mammals. Here are swimming mammals, here are ocean adjacent mammals. And then we have these odd ones like mammals that are fly, like a bat, and a platypus that's a mammal, but I had to look up, so it's kind of monotreme. And then we have, of course, here we have a cheetah, which I don't know why the cheetah ended up there. But what's remarkable is these are categories that the computer constructed without me doing anything. I did not create these categories of these items. It created the categories because it saw the similarities in the features. So you can see over here, the Sphinx cat and the house cat are right there next to each other because the model identified that they share most of the same features, but it's not because I said not because I said these things go together. That's what the model determined based on its experience, right? So it knows these differences, but it didn't have rules to do this. And so the key here is really the experience that the student has. So we learn by associating the features with labels. And what we learn depends on what it experiences. So the exact input to the model matters. So for example, if you see a model, if you give the model only reptiles and birds, and then you get the features of the bat, including that it has fur and so on, the model will still categorize that as a bird because it doesn't have any other experience besides a bat to tell it that it's something different, right? And so basically what this tells us is the experiences we give kids are really critical. I'm going to talk about the kinds of experiences we want kids to have. Okay, and this little thing in the middle here is called a hidden unit, and this is the key to how this model works. And I'm going to show you how it works with actual words and rather than doing it with little pictures of animals. Okay, so let's talk about these little circles in the middle, right? These circles in the middle are called hidden units, but really what they represent is kind of like a neuron. Let me explain. So in a simulation of how this works, the simulation is important, but it also reflects how learning works in the human mind. We have letters on one side and we have sounds on the other side, okay? So this model I'm gonna show you only does letter to sounds, right? This one doesn't involve the meanings. This one just focuses on the letters and sounds. So all the letters and all the sounds and the words. And we have a bunch of these hidden units, okay? And these hidden units connect letters the letters connect to all the hidden units. And this is true for all the letters. And all of those hidden units connect to all of these sounds. Okay, one more. Okay, and so what does this mean? This means that we have these intermediate kind of processing structures in our brains that will allow us to connect inputs to outputs. Now, people call these models neurally inspired because it's not necessarily exactly how a neuron works. But I want to describe it sort of in that way, in the sense that you have the sort of the hidden unit here is sort of like a neuron. And the neuron connects the input through an axon, right? So axons are little, tendrily things that connect our neurons. And you can have multiple of those axons connect to that same neuron. And then on the other side, you have the sounds. And so basically, these are the set of kind of units in our brain that allow us to connect inputs and outputs, right? And this is what happens. So I'm going to explain to you how these models work. I'm going to actually show you if you got this on LinkedIn or on Facebook, I'm going to show you the thing that was actually on there in a minute. But I want to explain how it works first. So basically what the model does, you say to the model, essentially, try this word, and it says something, and it's going to guess the first time. You'll see this when I show you the simulation. In this case, it's going to say cell. And I say, no, that's not cell. That word is cat. Okay, so here is what happens in that process. The first thing that happens in this model is that the reader identified the letters. So some of those letters are not relevant for this. So it's just focusing on the letters that it sees. Okay, and then it uses model, and then so we take out those sort of inputs because they're not relevant here. And then the reader guesses the pronunciation, and it says cell, right? So the reader says cell, and we say, no, that's wrong. So the student gets the model gets the correction, and the teacher says, no, cell is wrong. And I turn these kind of purplish to, if you can't see the purple, it's just basically you can see the S, the E, and the L now are kind of being restricted, essentially. I'm saying, like, no, those are no good. Okay. And so the model then learned those things are best associated with these sounds. Okay. And what that means is then we change the structure of the model so that we increase the strength of the connections between these kinds of things. So we see that there are these stronger connections between these units and these inputs and outputs. Now, I did it this way by kind of thickening these lines to illustrate the strength of this connection. What you're going to see in the real model is it is not nearly this clean. We don't have one letter, a hidden unit, and sort of it really clearly links to a single output. We really use all of this information at one time, and I'm going to show you how that works. And so that's we're going to look at the actual simulation now, so we can see how this actually works. Okay, so let me bring up my example. So I said that this would be available online. It now is. So if you go to devinkearns.com, you can see word reading simulator. So now it's there. But you have to promise you're going to pay attention to this on the screen, not to your computer at home. I probably should never have told you that, since probably everyone's going to just start doing that. But that's okay. Okay, so let me explain what this does. So this basically shows this is a model, and I'm going to show you how it works. So basically, we have inputs are the letters on the left side here, and they're shown up here. And we're only using some of them. This only does the top 100 most common words in English. Okay. And so it has this so we have the letters, the onset, that means the things before the vowel, we have the vowels, and then the codas are the letters after. Okay. And so what we are doing here is trying to predict the pronunciation of the word cat. And so this is written in IPA, but for those of you who are like, could you please just give me the thing I'm used to, which is like the thing in the dictionary? Here it is. I have this, you can click that to change it to sound code. Also, by the way, there's a how to use button here too, if you want to look at this later. So you have cat, and the model has never learned anything. This is epic, which means it's sort of like round, 0. So it's 0 of 200. It has 0 knowledge, never done anything before. It guesses that cat says vug, which is not right. Okay, and this is what the model looks like. So the state of the model is that it has these inputs, the letters, it has these hidden units I was talking about, it has the outputs, and these are all the sounds in the word. Here are the consonant sounds, here are the vowel sounds, and here are the end consonant sounds. And you can see here that all of the letters are connected, all of the hidden units, and all the hidden units are connected to all those outputs. And I'm not going to go through the math. I have a longer version of simulation where you can look at the math. I know some of you are mathy folks who will probably want that. I have a version of this where you can look at all the math that goes into it. But basically, these inputs are these strengths. Remember I said I kind of made them different thicknesses. So this line is slightly thicker than the other one. This means that they're sort of like stronger connections. Basically, none of these is particularly thick because they're all randomly started. This is why it said, what did it say? It said bug because it doesn't know. So you can see here that it was supposed to say, but the one, I put an X on this one, the 0.8, which is the strongest activation, the one that sort of thought was the right answer, because that was the one that like got the most activation. What does that mean? It got the most information from this hidden unit structure, from the neurons. What this means is that we figured out the answer by connecting all this input information to these hidden units and then to the outputs. What you'll notice here is that there are 25 hidden units, but there are 100 words. And what I'm going to show you in a minute is that this model can figure out how to read all 100 words without learning anything, without knowing anything in advance, as long as it learns through getting the information. It tries it out. It gets the right answer. Like a teacher, like me, I say, no, that's not the right answer. And it adjusts the structure. It sort of makes these lines thicker or thinner and help it get the answer better. So let's watch it go. So if you press play, it's going to play through all this. You're going to see how it changes over time. It'll also show you how it performs on cat over time. So it'll show you what it does. I'm going to play the first couple if I click +1. So after one round of training, it does 100, it's done 100 words. It hasn't just read the exact 100 words it learned. It can learn kind of random words. It's changed the structure. So now there's a bunch of stuff. It's already determined that if it gets C, A, and T, it's more likely to come up with, it's going to come up with, where's the X? Comes up with the B, and then an A, and then a T. So It's still wrong in a lot of ways, right? The longest bar here is the 0.11, which is not very high. So it doesn't have a lot of confidence with that, but it is changing the structure. By the second go round now it's up to here. It's really identified that the A is the right one. And so it's really getting confident about that. And same thing with the T after reading 200 words. And now let's let it run. The words correct, or what percentage of the words it knows that are correct. All right, I'm going to pause it because it basically knows at this point. So by 88 iterations, it can read 99% of all words. And so, or sorry, 99% of all words and 99.7% of all the sounds in the words. Okay. So I want to show you a couple of things about this that I think are kind of cool. First is that you say like, well, yeah, it knows 100 words because it read them a bunch of times. True. However, it can also read made up words. So you can give it dat, which is a made up word, and it will tell you that it's dat. It doesn't guess, right? It could give it yat. Yat, it doesn't know as well, so it thinks it's gat because it hasn't gotten good enough. I'm not sure what happens. Actually, look at that. So this is a great example. So basically the model between here and here had not yet figured out that when you have the Y at the beginning, it says the Y sound, but it basically figured that out. So you can play around with these. We can do words that like has, which are words that like have, irregularities in them. So this has picked up on this. Does it get gas right? Yes, it says that gas is gas. Now it did learn gas, right? But that's fine. So what do you think it's going to do when I do DAS? It says DAS, right? Because why I can't exactly tell you. I can just tell you that the model is the reason that it did this. So you can play around with this yourself. But what this is designed to illustrate is that this model has learned to read these words and a whole bunch of other words that it's never seen before correctly because of the structure of the model. And the reason that's important is it tells us that when we think about the way kids read words, they're not reading them using rules, even though it looks like that. So learning doesn't involve rules. We decide the rules after the fact, just like we categorize the animals. That's a cat, even though it doesn't have any hair like a sphinx cat, right? But this again means the structure of the environment matters. So what we give the kids as inputs is really important, okay? And this is what I'm going to talk about, is one of the things I'm going to talk about when I talk about implications for teaching, which is what I'm going to turn to now. Okay, so the first implication is that we need to teach kids multiple units in the words, right? So there's this kind of debate about whether or not we should teach kids phonograms, right? So phonograms are body rhyme units, also known people often call them word families, but word family is not a technical term. You can use that with kids for certain, but phonogram is the term that some reading researchers use. I think it's kind of helpful. And technically, you ask like psychologists, they're body rhyme units. So ANK in rank, this is if we have the whole word is rank, the body is ANK. Sorry, no, the body is, let's see, body rhyme. The body is what is it? The rhyme body. Oh, yeah, the body is the whole word. Sorry. The body is the spoken form, and the rhyme is the body is the written form. The rhyme is the spoken form. Okay, so ANK says ank. The body is ANK, and the pronunciation of the body is ank, right? So that's how you say ank. So that's and it's the vowel sound and everything that comes after it. So in paint, that would be ain't, right? And so within a single syllable. So and the reason I talk about this is that some people have argued like you shouldn't teach kids these because it's, they should just focus on the individual letter sounds because you can figure out any word using letter sounds. That is true, but there's no reason that teaching some of these phonograms can't facilitate that process. And there are researchers who've done studies to show that when you teach kids some phonograms, it's helpful. And so one of those is from a researcher named Maureen Lovett, who designed this keyword strategy. And in her program, Dr. Lovett and her colleagues designed it to do exactly this. So they first teach individual letter sounds, and then they add in these keywords. And the keywords are basically phonograms that they teach the kids. And so the way that they do this is they have kind of a key word that is kind of the reference word. And so in this way of doing it, they say, first, I check mark the vowel AI. So here's the AI. The spelling pattern is AIN. The keyword is rain. So they have a keyword that goes with these patterns to remind them of that. And so then if I know rain, I know stain. Okay. Then you know if you have gain, you can do the same thing. If I know rain, I know gain. And then you can say, if I know rain, I know maintain, right? So that's the same kind of thing. So this strategy has has been effective in programs like Dr. Lovett's program that have shown to have positive effects on student achievement. So that's why I suggest considering using a keyword strategy. You don't have to do it exactly this way, but it's not a bad thing to do. It's also the case that teaching the kids individual letter sounds is the better first stage because of the way our brains are developing sensitivity over time. But this is a good strategy to use. The other thing we should do is teach kids about morphemes, right? These are spoken and written letter combinations that represent concepts. RE says re, it means again. ER says it's either someone who or comparative adjective. And morphology helps readers in a couple of ways. One way does involve just the spelling. So if you look at these two words, which of them is the right one? Or sorry, which of them, you don't know what the right one is. Which of those is easier to read? You tell me. You don't have to type in the chat, it might take a long time, but basically, like, I'm assuming you said the bottom one, right? You've probably heard before because it's like, one of those longest word kind of examples, right? But the question is, why was it easier to read this one, the anti-disestablishmentarianism, rather than humu humu nuku nuku apua? It's because of the chunks. We have these bigger units in the words that allow us to do this. So in humu humu, I can kind of use a little pen here to circle these. So I can say that the who, the mu, the hue, and mu, and so on. And so you can break it into those parts, but they're little parts. Because these are larger parts, it's easier for us to process these words in chunks, right? So that's why it's really valuable to learn not just about the individual letters. And this is exactly backed up by the cognitive science, which shows us that we represent words at multiple levels. Now, there's also a whole other piece of this that I'm not going to talk about, which is that we use this information for meaning as well. So I'm not getting into that here, but morphemes are useful to teach even if you're just focusing on them for the purpose of pronouncing words. Okay. So there's a strategy that goes with this. The strategy is called the peeling off strategy. And so the way to do this strategy is you can create a peeling off tree that has affixes on it. So this is my peeling off tree. It doesn't have to look like a tree, but this is also from Dr. Lovett's program. It's in other things as well, but hers is really the one that I did it again. I went to the end of the presentation. I'm so sorry. I'll have to stop again. So in her let's see, how do I stop sharing? I did. Sorry, we'll come back to that in a second. So in her program, Dr. Lovett designed this so that you would learn this keyword strategy. The list of affixes that I'm going to come back to is on my website. So if you go to devinkearns.com, there is a page that shows let's see, I'm just going to scroll to my morpheme page. Okay. Okay. Not let that happen again. Okay. Don't press the end button. Okay. There's a list of affixes on my website that you can access. So let me see if I'll bring up my website again. So if you go to devinkearns.com, I'm embarrassed to tell you I even have this website, but it is what it is. So if you click on for teachers and you click on materials, there is a list of affixes here. Where is it? It's syllable, affix, and root list that I compiled, so you can use that as a tool as well. So that's just another resource for you. So you have your peeling off tree with your affixes. You teach students the affix pronunciations, like this is the prefix pre. What is it? Pre. Good, spell it, P-R-E. Let's add to peeling off tree. And there we put it on the peeling off tree, and you practice that a lot. Then we can use a peeling off strategy when we read words. So we have a word like statement. We find the affix from the peeling off tree, meant. We can circle the affix. We read the base word, state. And then we read the affix meant, and we put that whole thing together. And we can do that peeling off strategy with a word that's hard for us. So here's my peeling off tree for pseudo, hypo, ism, and para. And we're going to use this. I'm going to use a syllable card to break it into parts. So here's a long word. We can use a syllable card to break it into parts. So I can see the first part. I say pseudo. You can say it with me. Pseudo, hypo, ism at the end. We have this part in the middle. That's thyroid, and there's thyroid. And then we can chunk it. So you can say it with me. Pseudo hypoparathyroidism. There you go. Now you're writing one of the longest words in the world. So that is an example of how to use the peeling off strategy, which again depends not just on individual letter sounds, it depends on other things. The other thing that's important is that we have to decide which spellings are useful to teach. So not all the spellings and words are equally useful. Okay. So we only have about 5 minutes remaining. So I'm going to tell you the answer to this one rather than having you figure it out. But if you think about all the spellings of the long A sound, right? Here are a bunch of spellings of the long A sound. There's A, AI, A consonant E, there's the AY. There's also EA, EY, EI, and EIGH. And then there's also ET and AE, like in ballet and aerospace. Now, I think the last two are kind of cheating, but basically, if we look at all of those, and I was to ask you, would you teach these? If these are all the different ones we have, like, would you decide to teach them or not, right? Well, then the question is, you have to decide the order of these by frequency, and then think about, like, is it worth it? Right? Because we have limited time and we want to give kids the input that's going to be most efficient for them to build that network. And so here is the frequency by pronunciation of these. So if you look at all of these and you look at how often the frequency of these, the percentage means of all the examples of when you hear the A sound, here's that spelling. So what you can see here is you only really need the top four. So people sometimes teach kids EIGH. The data don't really support that because the frequency of EIGH is so low that it's not necessarily going to be helpful to them, right? I have a sound spelling sequence chart that I actually realized is on the website this morning when I was looking at it, so I need to put it up there. But I have a sound spelling sequence chart that is not, it's not sacrosanct, it's not necessarily the fanciest thing on earth, but it just gives you an example of kind of like a list of kind of 80 some odd that I thought are particularly important. But it's only a guide, so I put it there like that. The related thing is, so we have this thing where A says A, yes, that's great. And all English letters do have things that work, but because even the worst words do have some reliable sound spellings, sometimes I ask people like, well, can you give me a word that's nothing reliable in it? The words that people say are who, but I put in, the H is in pink there, the H in the middle there is the sound, so that one works. In I, the Y kind of works. And then in of, it is true, nothing in of really says it's the most typical sound. And then bosun, like, still has a bunch of problems, but it sort of works. So, and then that's the word biddle. So even these worst offenders still have something that works. And so we do want to teach kids about the things that are reliable because that will help them build a network. Phonics is essentially helpful because it helps prime the network by giving it the information that will help it grow at the fastest possible rate. And that brings me to the last thing, which is linking to the lexicon, which is to say that we need to make connections to the meaning parts of words, even when we're trying to read them, okay? We already had these sound meaning connections. We're building these letter sound connections using the model that I taught. And we want the kids to be able to, when they see the word, to get the meaning really quickly. Context is helpful too, right? And so people say, well, if you say that, then why don't we just guess like you talked about? It's because we have to get the word through the network, and then the context can be helpful as a confirmatory strategy. And which is to say, you say the sentence, you're like, wait, does that make sense? So when you ask kids, does that make sense? That's helpful after they sound it out using all the information. Remember, we're not going to guess because the data don't support that. It doesn't align with cognitive science, right? So, the strategy like lips the fish and skipping the word and going back, that's not focusing on the pronunciation of the word. And then eagle eye, which is like the picture strategy, those are terrible to use. And so what I would say is we want to teach kids to link to the lexicon, which means make the connection to meaning. I'm not saying use whole language. I'm actually saying don't use whole language. But what I am saying is use reasonably familiar units. So I'll end with this point, is that some reading programs have kids read words that aren't really words. So like if you look at this list of words, which is from a common intervention program for kids, not all of these words are likely to be known to students. And so if you're going to teach them to read words, you need to give them words that are more familiar to them. And that is the last thing that I have to say after almost an hour of information. So I'm sorry that I did not have a chance to answer any questions, but I think we got some applicable implications, which is great.
Thank you. Devin, this is great. It's so informative. I know we schedule for 1 hour, but if you are available to stay a bit longer, we have a few questions open. I wonder if you can go through them.
Sure, yeah. Okay, so let's see. I'll start with the I'm confused. I'm confused with the correlation in the model. How are you relating or aligning the neural networks to the way kids learn? The neural networks are the way kids learn. The point is that we learn in a statistical way. I don't want to say statistical, that's the answer, but it's kind of confusing to say that. What I mean is that we learn gradually through the use of this neural information. It's not that we're, so the reason I do this is to make it clear. It's not that A says ah. Yes, when you see A, you say ah, but it's not because your brain knows A, ah is directly connected. It's because it's connected through this entire system. And what that means is that we want to be careful about the input that we give kids because we want to make sure we give them things that are helpful to them. It also means that the experience we give kids matters. And so, which also means we don't want to just give kids decodable text. We want to give them other kinds of text so they can generalize, so they have experiences that help them go beyond just what's decodable. So let's see. Varun has a good question, but he can email me about that after it's a long one. What's quiet, supposed to be quiet? Okay, Clarabelle asks about bilingual, multiple lingual students. Yeah, basically there is, depending on the orthography, the letter system, it can be really helpful to have that background knowledge for reading another language. It definitely improves knowledge in some ways in the meaning system, and there are data that do indicate that having two languages there's some simulation work that shows that having two languages in your background does result in more effective processing. And so with Spanish and English, at least, I don't know about whether it's like a language with a different kind of character structure, like if we were using like Arabic or something like that. But it is clear that at least for Spanish, having another language can be helpful. What would you please talk more about do PA exercise with letters? Yeah. So basically, some people have been saying, don't do letters, it's bad. What I'm trying to convince you all is that letters are helpful for reading because when you add the letters in, it helps kids draw the connection between the sound and the letter so they can read the word. If you just focus on the sounds, they don't do that. If kids haven't started reading yet, it's totally fine to focus on the sounds because you want them, as I said, it's important for them to sort of have the understanding that, like, the sounds are k and a and t, right? It's important for them to know those individual sounds. But as soon as we can link them to letters, the better, because then the kids have more input information and will actually grow the network faster. We'll be able to learn more quickly. So that's why. So basically, there are programs that only do PA without letters for a long time. That is bad. I'm going to tell you straight out, do not do PA exercises in grades 2 up. Full stop. Unless, I'm not even going to say, like, if kids have very, very, very severe phonological problems, maybe, but even then I would question it. Don't do it. So if you have a program where it says in second grade to do PA exercises, I don't recommend it. Full stop. Their data don't support that as a strategy. And then I think Drew can be the last one. There's a ton of other good things, but you guys can all email me too. So Drew asks, it seems like students benefit from not fully controlled decodable text in order to grow the network. Is there an optimal decodability percentage you recommend? I love this question. So Drew's asking, like, should we do like like this percent decodable or whatever? The answer is no, we do not know. I've done some simulation work where we've shown that maybe about if 20% of your texts are decodable, it might be helpful. We don't know that for sure. That was just one simulation study that we did. So I don't want to say it with confidence. What I think the sweet spot is controlled text in a way. I think just giving kids like trade books that have no control is a real challenge. But I think that, and purely decodable books kind of maybe restrict things too much, but having controlled text where there's some things that they have to generalize, but a lot of it is controlled for the difficulty can be really helpful. So anyway, you all can, email me questions later. You got great questions. I would love to answer them. And, I know many of you, a lot of these are folks who are asking questions I know anyway, so you guys can always email me. But anyway, Christine, thank you for having me. I hope that this was helpful, and I look forward to seeing you, of course, and Kristen too.
Yes. Thank you so much. This is really wonderful. So the audiences, if you have questions, I think you can find Devin's email on his website.
It's on the bottom of the screen too, but yes.
Oh yeah, yeah.
Yeah, but it's just go to devinkearns.com and everything is
That's
there too. So
easiest. All right. Thank you so much for
all
joining
right.
us. We hope today's discussion really provided quite a valuable insight. Clearly, there's a lot more question and discussion people want to have. So hopefully this can continue offline. So we appreciate everybody's time and joining us today. And we're looking forward to seeing you perhaps in our future bi-monthly talk. So next one will be September 2nd, Friday. I don't have the dates. Kristen, do you have the dates? Is this?
It'll be Friday, sorry about that. I can't believe it's already September coming up, but September 11th at 12 p.m. Stay tuned and check out our website and newsletter, and we look forward to sharing the update soon.
Thank you. Thank you so much, everybody.
Hi, everyone.